So this is what happens when you tell an engineer to make a presentation. He draws like Ferris drawing a browser out of a WebAssembly sleeve with libp2p and WebRTC on either side. So I hope you guys can really grasp my, thank you, Molly. That's great. That's my artistic impression of what's going on here. So yeah, I'm going to talk about all this. I've got about 12 slides. Hopefully I don't ramble on too much, and I like to move. So this is my truncated repo for the past, say, 2019. And you can't read any of the text because apparently it doesn't render very well on a black screen. So anyway, the first yellow dot is I'm an engineer. I'm actually an ex-military engineer. I spent 20 years in the Navy as naval engineering officer, which means I moved around a lot and I missed a lot of mail. And I was talking to Nico about this earlier. At one point in 2019, I screamed into the internet and I said, why can't I just press the magical blue button and blast my address out to everyone? And that took me on the DWeb branch, which there's a whole lot of IPFS stuff written on there, which you can't read, unfortunately. But like libp2p and IPFS and IPLD and IPNS and all the IPs. I went through all the IPs. In addition to also DAT. I started with DAT actually in hypercore, and it's called Hole Punch now. And a whole raft of blockchain options. And I found, well, back in the day, 2019, 2020, there was a lot of hype, and it was difficult to sift through all the hype to find what actually works. And I think the main reason why I'm here now is I kind of circled back to libp2p because this is the thing that works. You know, like Steve said, that's embedded in dozens and dozens of projects. And so I worked. And then the blue branch there, it says Rust and Wasm. So I sort of branched off libp2p into Rust and Wasm. I'm an old school JavaScript guy. Like I'm JavaScript from the jQuery days and probably a little bit before. I loved JavaScript because it was so easy and you could build stuff really cool. But I had two basically North Star goals with this, which was independence. You know, if we can run our own node at home or on mobile, and I'm so glad Daniel went first because he was talking about the TLS certs and whatnot. It's a problem if you're running a node at home, right? You need to have a domain name and do all this jazz. And also the browser, so we're on the same page. And actually, the next idea I have for universal connectivity, and I put that in the notes, is like a Towery app with libp2p at home, so you could have a home node as a native app, and I put that in the notes so we won't forget. But this is what I was going for, and you can't really get this in a whole lot of places. You can get the independence and adoption. Anyway, next slide. Basically, in other words, I wonder if this, can I tap on this? Will this play? Yeah. Anyway, Jim Carrey from the movie Liar Liar, I'm a big fan. He's basically, I shouldn't have to go through the cloud to go from my phone to my home computer and back, right? Like, why do I have to sift this through Google Drive or email it to myself? We should be able to solve for this. So this is essentially where we are. Uh-oh. There we go. So that brings us to WebRTC. So again, glad Daniel went first. No TLS certificate. Well, I guess you should say self-signed TLS certificate is the technical term, right? But you don't need a domain name. You self-sign it, and so it's very independent. So we get the independence, great. I don't need to have a domain name. We can have people running a WebRTC node at home, fantastic. We also get browser, it works in the browser, WebRTC, web browsers, right? So very compatible. So we get the usage and the adoption there, that's fantastic. WebRTC is mostly known for the web and the audio and the media, but there's a little known data channel that's also available in WebRTC, which is what we use in libp2p to send the bytes across. We're not actually using, you know, what it was intended for. We're using that, oh yeah, we'll also tack on this data channel and send data across. So that gives us sort of the, I have this for a reason, for the triad here, where you've got your home node and your browsers, and you can send that file from your browser back to your home node and back without having to go through, you know, Google Drive or anything like that. Okay, that's cool, Doug. But Rust in the browser, really? Why? I had this conversation 2 days ago, like, really? You're gonna do front-end development in Rust? Okay. Yeah, so I had the home node running in Rust, fantastic. And then you have the browser, and you have to go to JS libp2p, right? Because JavaScript was the implementation that had WebRTC available. And so start developing in 2 libp2p stacks and back and forth and back and forth. The context switching was crazy. I'm glad the text shows up in this. Yeah, the context switching between JavaScript and Rust was just killing me. And I said, we really need to have the Rust version of WebRTC so that, you know, the development process is streamlined. And I was having gossip sub issues. And so try debugging between JavaScript, libp2p, Rust, libp2p, JavaScript, gossip sub, Rust, gossip sub. You know, and then there's a different architecture, the way Rust libp2p has set up, and a different way JavaScript is set up. So it was just a nightmare. So it had to be done. But a side effect is we get this sort of Wasm native. Rust is the most capable language to compile the WebAssembly, right? I mean, you can do it with the other languages, but I'm pretty sure Rust was the first one to do it. I'm not a Wasm expert. And I say Wasm because it sounds like awesome instead of Wasm, which just sounds like something else. And so this also gives us access to build libp2p apps with a growing ecosystem of front-end frameworks. And so I've listed a few of them here, like Leptos is the one I like. It's got fine-grained reactivity like you would get in Svelte, Nikos. But there's also U, Dioxys, Sycamore, eGUI, and I'm sure the list is growing all the time. And that enables you to pull in all these amazing libraries that are written in Rust and published on GitHub or published on crates.io. And I don't know if you've noticed it, but this is one of the reasons why I got into Rust is I observed a lot of ecosystems and academics, researchers, developers putting a lot of their crypto in Rust. So if you want the good stuff, you've got to use the Rust crate. And you can, you know, as we'll see it a little bit, kind of go through JavaScript and the bindings and whatnot, but it is a lot easier just to be able to import it in the same language. So we get all these benefits by going browser, Rust, Wasm. And so instead of all this context switching and back and forth, we just have Rust all the way down. And so that's the why. So small disclaimer, so we've done the browser to server part, and the next step is the browser to browser part. Just need to find some capacity to do it, and there is a GitHub issue already open for it. It's next on the to-do list, and then once that is complete, we'll have the full circle browser to browser and browser to home node connectivity, which will be amazing. All right. Whoa, Doug, just slow down. I read this article 3 years ago that said, you know, WebAssembly, I don't know, like you can't see it in the browser and it's all compiled in there. Isn't this a little bit dangerous to, you know, add networking to WebAssembly apps? Well, like anything in WebAssembly in the browser already has networking anyway. You can't sandbox the networking. But the good news is everything else you actually can sandbox. And I'll cover this in a bit. And this is actually even more exciting. I'm really, really excited about the sandboxed aspect of WebAssembly, which we can add to our apps. And it not requires two things, but you know, sans.io, there's this concept of sans.io, which is where you remove the input-output from your application and kind of segregate it into a different module so that your app can run, you know, with any implementation of input-output. So it's not tied. And you know, you get that modularity that we all learned about in our Bachelor's of Engineering degree. And then I added this last point, which I call sans UI. And so I don't know anybody who remembers Winamp and Winamp skins. Steve, maybe? No? Okay. Thank you. Yes, Winamp skins. Sorry. Winamp skins allowed you to put whatever UI you wanted on the music you were playing. Okay, so you know this was lost with these monolithic apps that we've got, and so I'm trying to influence the sans UI movement, where you can have the core app functionality, and then allow people to put on their own skin or user interface on top of that, and still have that app functionality. So here are some varieties of WebAssembly. So the first one is Wasm BindGen. That's the one we used for libp2p because it's got what they call WebSys and JSys built into it, and it gives us the bindings to rust-libp to WebRTC, and it's the same one it's used for web transport. But there's a few really interesting and exciting emerging, and again, this is all emergent, it's all very experimental, so there's not a whole lot of documentation, publications. examples out there, but they do exist. The second one is called Wasm interface types. And the IO bindings for that is basically WASI and user defined. So this is where you get that sandboxing. You actually define what inputs and outputs or imports and exports you get out of this Wasm app. And it runs in a sandbox code anywhere, which is essentially anywhere WASI runs or anywhere Wasm time runs. So JavaScript, Rust, Go, I think Python as well. There's a few implementations that are already up and running. Very, very exciting. But that's async code. So there's another option called Wasm Reactive Streams or Wasm RS integrated into Wick, which is the async version of that. They've done some really interesting work. I did an experiment, and this is lab week, so we're talking about experiments, right? I did an experiment with Sans UI called Werbo, which is where you could have that WIT model with UI. So you could have literally a sandboxed UI component, which is kind of mind-blowing if you think about it. And I'm still trying to figure out how IPVM fits into this whole thing. They've got their IO is function arguments. They're at the function level, whereas everything 1 through 4 is sort of at the app level, so app level, function level. And I know that not a whole lot of people know about this, so I'm happy to talk about all of this stuff and where they could all fit in and how you can build apps with these components. But why? Like this is very complicated, right? We're going to do a lot of work to sandbox and componentize and modularize all this. Well, essentially, so for the HackFS hackathon this year, another experiment, is I wanted to bundle up the IPNS encoding into a WebAssembly component so that it could be used anywhere. And it was successful. We were able to bundle it up and use it in the web to encode and decode. So what I found was, oh, hello. What I found was we weren't reusing these components. They're all kind of built together in libp2p as big monoliths. And so I thought, well, if I'm going to develop something, I want to be able to export it and have like a Go developer use it. But right now, that's not really being done. And with a framework like this, we could do it. And then you've got the friendly crab sort of, cuddling the blue gopher saying, here, you can use my WebAssembly app because it's componentized and modular, and you just run it in your WASI environment, which is great. So it would look something like this. So this is kind of what we did already, and this is why I have this with WebRTC and libp2p. And then you'd have your core functionality sandboxed in the middle. And this is the part that you would write in Wasm interface types and just share amongst all your libp2p friends and saying, here, I've already built this implementation. Just feed it the imports and you'll get an export. And if you want a networking, just go over to the libp2p side. And then the bit on the end, the user interface, is the Sans IO part, which you can literally mix and match for, well, I don't like the UI that Doug built. I'm going to build my own because I'm a front-end developer. And you can use your own, yet keep the same core functionality. And actually, the JavaScript or the libp2p part doesn't even have to be the rust-libp2p implementation. It could be the Go implementation or whatever implementation you're using. And that allows us to compose our libp2p apps together and use each other's code and maybe only write the same code once, which would be streamline, I think, adoption and development, in my opinion. So I'm trying to foster this build once, run anywhere libp2p example. So a few ideas, unimplemented ideas. Imagine if you had implemented in FFmpeg an video encoder decoder, and you were broadcasting your video into this encoder decoder and then gossiping it out on GossipSub, and anyone else listening at the other end could encode and decode in whatever implementation they were having. You'd only want to write that once, because I haven't written it because it's, FFmpeg, and it would be a lot of work. So if you did write it, you probably wouldn't want other people to have to rewrite it in Go so that it could run in their system, or rewrite it in JavaScript. It would just be like, no, let's just write it once. Another idea, which actually I'm working on, is a proof system. So if I have a proof system that I want widely adopted, I'm going to write that once in a WebAssembly component and just offer it out for everybody to run. Another idea is a connected wallet. So if you have, and this is something that's near and dear to my heart, I'm going to be talking about on Friday at the Wallet Unconference, is, wallets, Edwards curves, you've got RSA, there's SecP, there's BLS, everything, right? So, there's so many, and there's more being added every day. Every time a new crypto paper comes out, somebody's going to have to re-implement it. Well, wouldn't it be neat if it was all modularized and you could, build your own wallet just by pulling in the components that you need and then compile once and, wow, you've got your own wallet. And if you want to back it up between your phone and your laptop, well, now we've got Rust WebRTC that can do that for you in a modularized component way. So just some ideas, and I'm sure there's more to come, but I thought I'd get the thought juices rolling. Oh boy. So do I need to learn Rust to do this? So I don't know, how many Rust developers in the crowd, or should I say like people who understand, can read? So, oh, actually, pretty good. Oh, wow, okay, great. That's fantastic. So I can just skip this slide. Yeah, I like to say that JavaScript, Rust has a steep learning curve, but a gentle maintenance curve. And JavaScript has a gentle learning curve, but a steep maintenance curve. And I mean, those of you who have built like large-scale JavaScript and like migrating to TypeScript ecosystems understand that. But I mean, the answer is really no. I mean, you can build WebAssembly in Rust or TinyGo and AssemblyScript in C++, but I recommend Rust. It really is a beautiful language. As someone who's been around since like the jQuery days, like I say, in Java before that, I've never seen a language like this, so I'm a big fan, and apparently some of you are as well, so that's great. And so yeah, that essentially concludes my talk. We have WebRTC in the browser now, and we have WebAssembly. There are really neat things we can build with it now that we can connect our laptops with our browsers and whatnot, and I'm really excited to talk to all of you about it. And I probably already have talked to some of you about it, and thank you. Thank you for having me in Protocol Labs.
Any quick questions for Doug?
Just a quick one. Hey, Doug, thanks for the presentation. What's the quick experience you guys have had with like the Rust to Wasm? Like, it's a crazy shifting landscape in the browser. Then there's also like the server side.
Okay.
With like threading and like promise, asyncify stuff. Like, have you guys had, what's the overall, it's figured out, it's fine for you guys in the Rust repo, or like, what's the experience with that? That's it.
So I'm not quite sure what your question is. Is it an easy build?
Have you had problems with getting your performant Rust code to work correctly when it's compiled with like Wasm bindgen in the browser?
Not
no
really.
problems? Okay.
No. Oh, but thank you for reminding me. So there, and yes, Daniel, there are examples in the repo, in the rust-libp2p repo. There's an example I insisted is one of the first things I wrote was, the test and the example and the demo to make sure it works. Because like I said, there are a bunch of frameworks that are launching, but that's just in vanilla Wasm. So it's essentially event handlers in WebAssembly, and it updates the page in a ping. Like, it's very, very basic, but it's enough to kind of get you going to run the example, which is fantastic. I love those examples in the repo, and I'm sure others do too.
Other questions? Yeah, okay.
Russell.
Hi, thanks, Doug. You said you were working on making composable Wasm for like libp2p, and so is your ideal world where like Go libp2p compiles to Wasm that Rust libp2p can consume, and vice versa? And have you been in touch with those core maintainers? How do you feel from maintainers on those teams and of their like willingness to do that? Because I'm a big fan of that. I think, I'm a big fan.
Okay, so I think the first question is no. I don't think the vision is to compile the whole libp2p stack to Wasm. I think Marco looked at something like that, and it's just the scope is huge. So I think if you think about it more like extensions or add-ons, or you bring a new protocol or you bring a new encoding that you want to stack on top of libp2p, like an IPNS replacement or a new protocol of some sort. Build that add-on in Wasm and then just plug it into the existing system. Because I think rewriting it would just be, it would be fantastic, but it's just a monstrous effort. And so no, I haven't talked to them about that because I think we kind of all know that it would be a huge effort. So just think of it as extensions, like building on top of, and this, like this slide here, the libp2p part on the left is your sort of monolithic app that has the networking built in. But if you want, and I think we all should, you know, extend our apps to third-party extensions, allow that to happen via a plugin system like this. Say, bring your own Wasm component, and heck, your own UI if you want, because how many, you know, libp2p apps do we want running at the same time simultaneously on the same device? Well, no. What if we have one core app and you can just extend it, extend it, extend it? So that's how I would see in an ideal world how we would do it, and I hope that addresses your question. Yeah.
Great.